Today's lesson is Chapter 9, Section 2, Angle Relationships and Parallel Lines. As we start today's lesson, you need to get out your notes that you took yesterday during class, and we're going to go through the definitions and talk about what they mean, and then we'll apply them to some problems. So the first term that we're going to talk about are adjacent angles, and they're angles that share the same side. So if we look at this example here, we have angle AXB, and then we have angle BXC. They are adjacent angles because they share the side XB. So adjacent angles are angles that share the same side. Vertical angles are angles that are across from each other when two lines intersect. So these two lines intersect. Angle 1 is adjacent to angle 3. And the thing that we know about angles 1 and 3 is that they are congruent. That means that they have the same measure. Here, angles 2 and 4 are across from each other, angle 2 and angle 4. And those angles are vertical angles, and we know that they are going to be equal to each other as well. Supplementary angles are two angles whose sum are 180 degrees, which means that these angles are going to make a straight line. They don't always have to be adjacent angles. They can be two angles whose sum is 180 degrees. In this case here, angle ABC and angle CBA are supplementary. That means that they make a straight line or 180 degrees. So we want to know how many degrees is this angle right here. If angle ABC is 120 degrees, what would angle CBD be equal to? Well, we can take 180 and subtract 120 from it, and we get 60. So angle CBD is 60 degrees. Complementary angles are angles whose sum are 90 degrees, or they make a right angle. Again, these angles can be adjacent angles, or they can be separate from each other. But angle PQR and angle RQS are complementary. They make a 90-degree angle. So to find the measure of angle PQR, we would take 90, because that's how many degrees are in a complement or a right angle, and we would subtract 30 from it, which means that angle PQR would equal 60 degrees. Corresponding lines are lie on the same side of the transversal in corresponding positions. So what we have here are two parallel lines, and they're cut by a transversal. And in this example here, you can see angle 1 and angle 5 are in yellow. If I were to take and move line B or line A on top of line B, 1 and 5 would be in the same position. So those angles are congruent. Just as angles 2 and 6 would be in the same position if I moved line A to go on top of line B. So angles 2 and 6 are congruent. Same here, angles 4 and 8 are both on the bottom left of the transversal, so those would also be congruent. And then angles 3 and 7 would also be congruent. Now, alternate interior angles are angles inside the parallel lines on opposite sides of the transversal. So we have a parallel line here, an angle or in line A, and then a parallel line here. And then this here is the transversal that cuts through those parallel lines. So alternate interior angles. So we're looking inside the parallel lines. So we're looking in this region here, in between the two parallel lines. And they're on opposite sides. Alternate means opposite. So 4 and 6 are alternate interior angles and they're going to be equal. So angle 4 is equal to angle 6. Just the same as 3 and 5 are also equal. So angle 3 is equal to angle 5. The transversal is the line that intersects the two lines. So this line that's highlighted here in yellow, or that I'm going to draw red over, that's called the transversal, and sometimes is labeled with a T. And then finally, congruent angles are angles with the same measurement. So if we look back up here at corresponding angles, angle 1 and angle 5 are congruent. Angle 2 is equal to angle 6. Angle 4 is equal to angle 8. And angle 3 is equal to angle 7. So let's look at some examples. If I know that the measure of angle 8 is 15, can I find some other angle measurements using the terms from the page before? Well, I know that if angle 8 is 15 degrees, then angle 6 must be 15 degrees because they are vertical angles. Well, then I also know that angle 8 and angle 5 make a straight line. So I could find angle 5, because 8 and 5 are supplementary, I could find angle 5 by taking 8 and subtracting 15, which is 165. So angle 5 is 165 degrees, and then angle 5 and angle 7 are vertical angles, so they are going to be congruent. So angle 7 is 165 degrees. We've now found all the angle measurements. Let's look at another example. In this diagram, lines A and B are parallel, and then this line here is the transversal that cuts the line, or intersects the two parallel lines. So let's see what we can find out here. I know that angle 3 is going to be 193 degrees, and the reason I know that is because angle 1 and angle 3 are vertical angles, and they're always equal. I could also use supplementary angles because angle 1 and angle 2 are supplementary. They make a straight line. So, whoops. I did this wrong. I did not mean for this to be 193 degrees. This is supposed to be 93 degrees. I'm very sorry. That one got in there on accident. So if this is 93 degrees, then angle 3 would be 93 degrees. So how would I find angle 2? I would take 180 and subtract 93 degrees from it, which would give me 87 degrees for angle 2. Well, now I know angle 4 would be 87 degrees because they are vertical angles, and vertical angles are equal to each other. So now how are we going to find the other angles? Well, angle 5 and angle 3 are alternate interior angles. They're on the inside of the parallel lines, opposite sides of the transversal, so that would be 93 degrees. We could also find that because angle 1 and angle 5 are also corresponding angles. Angle 7 would be 93 degrees because it's the vertical angle of angle 5, plus it's the corresponding angle to 93. Angle 4 and angle 6 are alternate interior angles inside the parallel lines, opposite sides of the transversal. So that means they're congruent, so that would be 87 degrees. And we could find angle 8 because it is the vertical angle of 6, so that would be 87 degrees as well. We could also use corresponding angles because angle 4 and angle 8 are also corresponding. So turn over your notes that you took yesterday in class, and I want you to take a few minutes, pause the video, and try the next two problems on your own. And when you're ready, you can turn the video back on and we will go over them together. Okay, welcome back. Hopefully you had time to finish up these problems. Let's take a look at number 1. If angle 8 is 20 degrees, we know angle 6 is 20 degrees because they're vertical angles. Angle 5 is the supplement to angle 6, so we would take 180 minus 20, which is 60 degrees. And angle 5 and angle 7 are vertical angles, so angle 7 would also be 60 degrees. Hopefully you got those right. Let's look at the next one. They tell us angle 2 is 79 degrees. We know angle 4 would be 79 degrees because it is the vertical angle. We could also find angle 8 because angle 4 and angle 8 are corresponding angles. They're in the same position, so that would be 79 degrees. Angle 8 and angle 6 are vertical angles, so that would be 79 degrees as well. Angle 6 is also the alternate interior to 4, and it is the corresponding angle to 2. So how are we going to find the rest of the angles? We take 180 and we subtract 79 because I know angle 1 and angle 2 are supplementary angles. And we get 101. So now I look at 1 and 3 are vertical angles. So angle 3 is 101 degrees. Angle 3 and angle 5 are alternate interior angles, so angle 5 would be 101 degrees, and angle 5 and angle 7 are vertical angles, so angle 7 would be 101 degrees. Please write down any questions that you have from this lesson and bring them to class tomorrow. Thanks for listening. Have a good night.